All right, so we've got more triangles going on today. In the last section, we introduced the law of sines. And the reason we needed to introduce something new and we needed a new idea is because we learned that if it's not a right triangle, we can't use SOHCAHTOA. So when it wasn't a right triangle, we can't use SOHCAHTOA, and then so we came up with the law of sines, and that worked great for a bunch of problems. And let's go ahead and take a look at this example here. So here we have this triangle up here. I know some things. I know I have a side of 5, side of 6, and an angle of 30 degrees. So there's no 90-degree angles. I can't use SOHCAHTOA, but let's go ahead and try and use law of sines. So I'm going to bring out my skeleton here for law of sines. And remember that we wanted to start with a known angle and a known side across. Well, it looks like I only know one angle, and I don't know the other two, which means I can't subtract from 180 and find any of them. So I only know one angle. Do I know the side across? I don't. No, it's also unknown. So basically, from what we were talking about with law of sines, it doesn't appear that I'll be able to use it. Let's go ahead and just try and see what happens. So I could go sine of 30 degrees divided by x, and then I have an option of either using the side of 6 or the side of 5. Either way, I don't know the angle across, so it doesn't really matter. Maybe I'll just pick the side of 6, just kind of randomly. And if I pick the side of 6, what's the angle opposite it? I don't know. So I could call it theta or something. But this is what happens when I don't know an angle and a side across, is I have two unknowns. So my two unknowns here, x, I don't know what that is, and theta, I don't know what that is either. So if you have two unknowns, you're not going to be able to solve it. So since I do not have an angle and a side across that are both known, I will not be able to solve using law of sines. And so this is kind of the entire reason behind why we need something new. So why do we need this law of cosines? Because law of sines didn't work, and of course, since there's no right angle, I can't use SOHCAHTOA. So we're going to be introducing this idea of law of sines. Okay, so in this nice little purple box here, this is kind of the official way that you will see law of cosines if you Google it or anything like that. And it is more complex than law of sines. It definitely is. However, it can be simplified from its official formats, I think. So officially, we could write it kind of three different ways, kind of depending on what side I'm trying to find or maybe what angle I'm trying to find. However, I think we can really just think of it in one step here. Okay, so as long as you understand what these letters represent, then we really only need one of these things. Okay, so I'm going to go ahead and talk through what the law of sines or law of cosines is and how we use it. So the law of cosines, I'm going to kind of read through what all of this equation means and stands for. So I'm going to say it starts with c squared. So I'm just going to go ahead and go c is one side. So I'm going to say that one side squared is equal to the sum, adding, of the other two sides, a and b, squared. And then minus 2, that's just always a 2, times, when they're right next to each other, it's times, a times b, which is the same sides that were right here. Those are the same. And then times the cosine of c. Notice that's a capital C, which is an angle. So that's the angle between sides a and b. So this will always be the angle between these two sides that are included. Okay, so one more time. One side squared equals the sum of the other two sides squared minus 2 times those same sides times the cosine of the angle. This is always an angle that I'm taking the cosine of. Cosine of the angle. Which angle? The angle that's between the two sides that I used here, A and B, in this scenario. So now we're going to solve this example using the law of cosines. And a nice hint with the law of cosines is to start on the left side, start with the unknown side, if there is an unknown side. Sometimes we'll actually know all the sides and we'll be looking for an angle, but if there is an unknown side, then I'm going to go ahead and start with that unknown side. So in our case, well, I know side 5, I know side 6, I don't know the side x. So I'm going to start with that side. So I'm going to go ahead and say, well, kind of my c squared, in this case, it's going to be x squared, my unknown side. So I have x squared. is equal to the sum of the other two sides squared. What are my other two sides? In this case, my other two sides are 5 and 6. So it's going to be the sum of the other two sides squared. And then minus 2, that's just always a 2, times those same sides. So what sides did I just use? 5 and 6. So that's what I'm going to use here. And then times the cosine, so times the cosine of the angle between those two sides. So what were those two sides? 5 and 6, 5 and 6. So here's 5 and 6, 5 and 6. What angle is between these two sides? Well, the angle between those two sides is 30 degrees. Okay, so let's go ahead and use 30 degrees. So now we've actually done most of the hard work, or at least some of the new, the stuff that we're learning that's new. And from here, I really just need to simplify, but we need to be very careful to make sure that we understand PEMDAS and that we're addressing PEMDAS appropriately. Okay, so PEMDAS essentially says, do your parentheses first, and then exponents, multiplication, division, addition, subtraction. However, with this particular setup using law of cosines, the main mistake that I see students make is right here. So it can be tempting to do this subtraction before this multiplication, which of course would not be following PEMDAS. So an example of what not to do would be to go 6 squared 36 and then minus 2 and get 34 or something, because that would be doing subtraction before this multiplication. So to kind of make sure that we do not make that mistake, a nice way to think about that, this is to group it into sections. So I like to group it into a section where I have all of that multiplication together. And then I'm just going to go ahead and make another section up here, that 5 squared plus 6 squared. So, okay, we have our left side. Don't forget your squared on that left side. I'm going to go ahead and just copy down this minus to make sure that I don't miss that as well. So let's go ahead and just put that minus in there. And now I can just go ahead and calculate my two sections. So if I go 5 squared plus 6 squared, or 25 plus 36, I'll get 61 there. And then I'm going to jump to my calculator for this second section, because I'm going to need to do the cosine of 30. And by the way, whenever you're doing trig functions on your calculator, for this course, we will always be in a degree mode. So make sure that your calculator is in the degree mode before you put this in. So in my calculator, I'm going to go ahead and put in the cosine of 30 and then times 6 times 5 times 2. I'm not going to include that negative because I already put it down there. So when I go the cosine of 30 times 6 times 5 times 2, I get 51.96. I'm just going to use my general rule of thumb of 2 decimals here. And I am kind of thinking ahead. I don't see any more trig functions, so I know I'm not finding an unknown angle, which means I'm not going to have to use an inverse trig function, which means I don't need to go out 4 decimals. If that doesn't make sense to you, and you don't really want to worry about when to use 4 and when not to use 4, you can always use 4, and that's fine. So now let's go ahead and calculate that right side. And the right side I get 9.04. All right, here is the second spot that a lot of students tend to make a mistake. It's easy to get excited here and say, hey, the left side is like pretty much isolated, and I have an answer that looks pretty nice on the right. So it looks like my answer is 9.04. However, x does not equal 9.04. X squared equals 9.04. X squared equals 9.04. We don't want to solve for x squared. I want to solve for x. So I'm not done. So now I need to undo the square on the left. So the opposite of squaring something is to take the square root. And so the square root and a square are opposites, so that will cancel and I'll be left with just x. Whatever I do to the left side, I have to do to the right. So I'm going to go ahead and take the square root of that right side, and that's going to leave me with 3.006. So if I'm going to round to 2 decimals for my final answer, about 3.01. So that side's going to be very, very close to 3. And let's just make sure that I know what I'm finding here. So I solved for x. Well, what is x? X is right here, okay? And I've now solved for x. So let's go ahead and just put that in. And let's now think about what if I wanted to maybe solve this entire triangle and I wanted to find the other angles. And the law of cosines is definitely a lot more work than the law of sines and more opportunities to make a mistake as well. So we should use law of cosines as little as possible. So let's go ahead and take a look. So maybe if I wanted to find another angle here, maybe let's go ahead and label this unknown angle as theta. Well, in order to use law of sines, I would need to know an angle and a side across. So let's go ahead and write out my skeleton here for the law of sines. So sine of an angle over its opposite side is equal to sine of an angle over its opposite side. Okay, so let's go ahead and take a look. To use law of sines, I need to know both an angle, and I know that angle, 30 degrees, and the side across. Oh yeah, now I do know the side across. So I can use law of sines. So I'm going to say, well, sine of 30, because I know 30, I know that angle, and divided by its opposite side, which I now know as well. That's 3.01. And then what do I want to find? I want to find theta. So I'm going to go sine of theta over 6. So sine of theta over 6. And then I could go ahead and solve using my law of sines technique, cross multiply and divide. You can watch the law of sines video again if you're not sure how to complete that. Let's do one more similar example here. So I'm going to go ahead and look at this triangle, and we kind of assume we're going to use law of cosines because that's what this whole section is about. But let's just do our check first because we won't always necessarily be told that. So when I look at this, do I have any 90-degree angles? No, so we can't use SOHCAHTOA. Do I know both an angle and a side across? No, so I can't use law of sines. So since it fails both of those checks, then I have to use law of cosines. And law of cosines, it's going to be best to start with an unknown side if we have an unknown side. So in this case, I do have an unknown side. It's z. So I'm going to go ahead and say z squared is equal to the sum of the other two sides squared. So I guess my other two sides are going to be 6 and 10. So 6 and 10 and 6 squared plus 10 squared. And of course that order doesn't matter. You could have gone 10 squared plus 6 squared. That's fine. And then minus 2 times those sides. Okay, I made myself some more room there. So 2 times those two sides. So 6 and 10 going in here. And then times the cosine of the angle between those two sides. So let's go ahead and take a look at this triangle here. So 6 and 10 were my two known sides. What's the angle between those two sides? Well, 40. So since I use 6 and 10 here and here, I'm going to use the angle between, which is 40. So the cosine of 40 degrees right there. All right, so now the left side is just z squared. Okay, here I'm going to go ahead and break it up into groups. So I'm going to have group 1, group 2. I'm just going to stick this minus in between them. All right, and now I have 6 squared plus 10 squared, 100 plus 6 squared, or 100 plus 36, which is 136. Okay, now I'm going to jump to my calculator to calculate that second section. And when I do that, I get 91.93. 91.93. Again, I am kind of thinking ahead here, and I'm saying, well, I'm going to be solving for an unknown side. I'm not solving for an unknown angle. Since I'm solving for an unknown side, I don't really need those 4 decimals. By the way, it's really important that you use your calculator and do these calculations with me and make sure that you're getting the same thing. Because sometimes students just watch how to do it and they assume they know how, and then it comes to an assessment and they don't know how to use their calculator and how to get the same answers when they're using their calculator. So it's really important that you guys figure out any issues now rather than later. Also, again, make sure that you are in degrees. Okay, so now I have z squared is equal to 44.07. 44.07. Okay, and I'm done, right? Wrong, because I have not solved for z. I've solved for z squared. So be really careful here. This is not your answer. I'm not done. I've solved for z squared, not z. So now I need to finish it up and get rid of the square. So how do we undo a square? Let's see if I can make this work here. Okay, I'm going to take the square root of both sides. And then I will be left with just z, which is what I wanted. So now I have just z, which is 6.64. Okay, and then that is my answer for z. And then if I did want to find the other angles, I could now use law of sines to find the other angles. One last example here, and we're going to do one that is a little bit different. So when I take a look at this triangle, I could do my initial checks of, do I have 90? No, can't use SOHCAHTOA. Do I have a known angle and a known side across? No, I don't. I don't know theta. And I, in fact, don't know any of the angles. So therefore, I know that I have to use law of cosines in this scenario. However, we were talking about in the last example how if you have an unknown side, then you want to start with an unknown side. But in this case, I know all the sides. They're 5, 3, and 7. I know all of them. And so if you do not have an unknown side, then you need to start with the side that is across from the unknown angle. So in general, with law of cosines, you either start with the unknown side or side across unknown angle. Okay? So in this case, where's my unknown angle? Since I don't have an unknown side, my unknown angle is here. What's the side across? 7. So I'm going to go ahead and start with a side of 7. This time I know it. So it's going to be 7 squared over here is equal to the sum of the other two sides squared. So what are my other two sides? Well, 5 and 3. So 5 squared plus 3 squared. Okay? And then that minus didn't show up. And then minus 2 times those sides. So what are those sides there? 5 and 3. And then times the cosine of the angle in between those sides. So I use sides 5 and 3 on the right side. So here I want the angle between sides 5 and 3. So where's sides 5 and 3? Right here. What angle is between sides 5 and 3? My unknown theta. Okay, and by the way, I'm just kind of thinking ahead a little bit. So if I have an unknown theta, that's an unknown angle. So I'm going to be solving for an unknown angle. Whenever I'm solving for an unknown angle, I want to use 4 decimal places to make sure I get an accurate answer. All right, so let's go ahead and see what I can do here. So 7 squared, 49. Well, that's easy. Okay, and then we said to try and group them together. So let's see what we can do here. So here, my first group, maybe I'll go ahead and write my minus just to make sure I don't forget that and leave it out. So I have 5 squared, 25, plus 9 squared, 3 squared, which is 9. So 25 and 9, well, that's going to be 34. And in the last two problems, we tried to group this entire section together. But this time, I don't know theta, so I can't calculate the cosine of theta. So I guess we'll have to just kind of leave that hanging out, and I'll just kind of group this part together. Okay, so 2 times 5 is 10. 10 times 3 is 30. So now I have 30 times the cosine of theta. All right, and then my goal is to solve for theta. So theta is my unknown, so that's the thing that I'm eventually trying to get by itself. Okay, here is something that's very tempting to do. So the next thing I'm going to say is incorrect, but I want to point out a common mistake. So it's very tempting to say, oh, well, 34 minus 30, that would just be 4, right? That would be so nice and easy. Let's just call it 4. But wait a second, that would be doing subtraction before multiplication. So that does not follow PEMDAS. So right now the 30 and the cosine of theta are connected by multiplication, and I cannot do this subtraction. So be really careful. Do not get sucked into that temptation there of doing PEMDAS incorrectly. Okay, so what do I need to do then? Let's think about some things that I need to get rid of. In order to get theta by itself, eventually I need to get rid of the cosine, the 30, the negative 30, and the 34. So let's go ahead and get rid of that 34. So if that's really, a positive 34, before that 34 is a positive sign, so I'm going to go ahead and subtract 34 to do the opposite. So I'm going to subtract 34 to do the opposite. That's going to leave me with 15 on the left, so I have a 15 over here, and I have a negative 30 times the cosine of theta over here. And so now it's negative 30 times the cosine of theta. So if I want to get rid of that negative 30, it's attached with a multiplication. So the opposite of multiplying by negative 30 would be to divide by negative 30. And that would cancel it on that right side. And if I do that on the right side, well, I've got to do that on the left side as well. So now the left side, I have 15 over negative 30. That's negative 1/2, or you could call it negative 0.5. Either way would be just fine. All right, and now I have the cosine of theta on the right side. Okay, let's make a little bit more room. So now I'm really close, but I need to get theta totally by itself. So I need to somehow undo the cosine. Well, how do I undo a cosine? What's the opposite operation of taking the cosine? Well, if you look on your calculator, right above cosine is inverse cosine because that's its inverse operation. That's how I will undo it. So to undo cosine and leave theta by itself, I'm going to take the inverse cosine, which will do the opposite and cancel and leave me with just theta, which is what I want. However, if I take the inverse cosine on the right side, well, I have to take the inverse cosine on the left. So now let's go ahead and plug it into your calculator, but do make sure that you are plugging in the inverse cosine. So press second and cosine, not cosine, but the inverse cosine by pressing second. And when I do that, I get 60. I get 60 here, so let's write that in. And so my theta, my unknown angle, and I'm going to put degrees there because it is an angle, is 60 degrees. Okay, and one more thing to point out here, we perhaps got kind of lucky by getting a nice decimal of just negative 0.5. But since I am taking an inverse trig function, then if this was a continuing decimal, I would want to use 4 numbers after the decimal. So we got a pretty nice decimal in this case, but if we did have a decimal that continued forever, then I would want to take 4 numbers after the decimal to take the inverse cosine of and get my final answer. Okay, so we are finished using the law of cosines, and I got my solution to be 60 degrees. Let's see if I can put it in here. So I did get my solution of 60 degrees for that unknown angle. And again, if I did want to solve for some of the other angles, maybe I'll just call this one, say, alpha, since I used theta earlier, then I can use law of sines. Why? Because I now know a known angle and a known side across. So I know that I could use the sine of 60 over 7, and then that could equal the sine of alpha over 3. And I could now solve for alpha, and I could go from there and get my answer.